be Mikhail. I'll be talking about mechanizing this JavaScript proposal.
Yeah, thank you for the introduction. My name is Mikhail.
I'm Aria. I'm a first-year master student.
And I'm Bergen. I'm also a first-year master student.
So we will be talking today about JavaScript, which is formally known as ECMAScript. The language is specified and standardized by the Technical Committee 39 of ECMA International. And the suggestions that this committee considers are formally called proposals. So essentially, a proposal is a description, is a technical description of a new language feature from various perspectives. And currently, the committee is looking into a few proposals, and we can roughly classify them into three groups. The first one being proposals that introduce new syntax, then proposals that introduce new semantics, and finally the largest groups are the proposals that introduce new APIs for the standard library of the language. So the way that the committee works is that each proposal has a champion group, maybe 2 to 5 persons, who actively work on the design of that proposal. And then when there are committee meetings that happen several times per year, those champions groups can present their proposals and get the feedback from the entire committee. The committee follows a pretty precise process when they consider and advance proposals. So a proposal can be in one of these 6 stages from 0 to 4 with some non-obvious stage numbers. So stage numbers, so each stage has particular requirements on the quality of the specification text, on the quality of the implementations, requirement to have testing, and so on and so forth. But nowhere here we can see any requirement to mechanize anything. And that is kind of expected. This is a huge industrial language, and we cannot really expect that. So we still thought to make this experiment and see whether some mechanization of some parts of some proposals could actually bring some results. And for that we have chosen the largest API proposal, which is called Temporal.
Right. So Temporal is a proposal to extend JavaScript APIs to deal with like date and time. So it defines a bunch of, or it specifies a bunch of types and functions to deal with date and time, year, month, day, time durations. It also supports time zones and also non-Gregorian calendars. And on top of all of that, it sort of claims compliance with all of the relevant industry standards like RFCs and the ISO standards. And so like this is obviously an enormous topic. It's also a very messy and complex topic. So as mentioned, it is the largest of all the proposals with over 200 pages of specification text. And that is maybe why it's a good candidate for this kind of mechanization, since like no human can hold all of this in their head.
To give some insight into what the specification looks like, we'll show a few examples. So you can see it has a pseudocode style, and here we have a sequence of assignments and arithmetic manipulations. Another example is that we have just a sequence of if statements, and then we have some more complex functions that utilize JavaScript semantics. The proposal has more than 500 functions, and 200 of them have to do with date and time manipulation. We ignore the function that utilize JavaScript's semantics directly when mechanizing. And so far we have mechanized 43 functions and have related proofs to them. And that resulted in 3,000 lines of Rocq code. So what do the function bodies look like? As we've seen already, we have a sequence of conditionals, sequence of let statements, and arithmetic manipulations. But you also have invocation of other functions, string manipulation, nested control flow, and rich text notation. Most of these were pretty straightforward to mechanize in Rocq, but some are not.
Okay. So yeah, this is an example of one that caused us a little bit more trouble. This function just converts a timestamp to the year containing that timestamp. And its definition in the specification is just the largest integer satisfying some predicate. And this is like a declarative specification in contrast to the much more imperative and algorithmic functions that are like the imperative and algorithmic definitions of most other functions. And so this doesn't like tell us how to implement it, which we wanted to do. Instead, we just came up with the simplest possible implementation we could sort of convince ourselves was correct, which is just a linear search. But that requires a termination proof, which causes us to need a monotonicity proof, requiring another monotonicity proof, and so on, for about 200 lines of Rocq code for this one function in the proposal. As mentioned, the proposal also claims to be compliant with various standards. An example of this is a function that turns a date time into a string representation, and the proposal says that this string is compatible with RFC 3339, which defines sort of the format for date and time strings for internet interoperability. And so we've mechanized the grammar from the RFC and have a nearly complete proof that the function actually respects this RFC. So
for the functions we mechanized, the most interesting ones have explicit assertions and preconditions. When mechanizing them, we have to prove these assertions and preconditions. But it happened that we failed to prove some of them, and then we verified, and we thought this to be an inconsistency in the specification. And this we verified by proving the negation of the predicates. Examples of these inconsistencies were that a function produces an invalid value, or that the function argument is out of bounds. We contacted the TC39 delegate, Philip Cemento, a champion of the proposal, with our findings, and he confirmed them to be indeed inconsistencies. After that, we collaborated to make changes to the specification text to then correct these inconsistencies.
So, trying to summarize, what are we actually interested in proving when looking into such a proposal? So we could sort of consider three directions. The first one is claims that are about internal consistency of the specification. So obviously all of the assertions and preconditions should hold. And things like this function does not throw an exception is an example of an internal consistency. The second group of claims that we are interested in proving is so-called expected behavior. So this is not explicitly given in the proposal specification text. So we had to elaborate this first. Things like if you add 0 to a time, it will not change the time. Or if you have two equal dates, then the difference between the two equal dates should be 0. Sort of in the style of property-based testing. And the third group of claims that we are interested in proving are claims that establish compliance to external, to various external artifacts, like the one we have heard a couple of minutes ago, that a certain function produces a certain string that is compliant with a certain industry standard. So if you have established all of these different kind of claims, we can be sort of more sure about the correctness of the specification. sort of coming back to our original motivation to have this experiment and see whether mechanization can somehow help finding inconsistencies in the specification. So we have a couple of reflection points. So the first one is this. So the algorithms in the specification are imperative, and we are trying to use a functional language. So is that a problem?
So like for the most part, it's been pretty all right, but there are a couple of places in our mechanization where the Rocq code does not sort of correspond as clearly to the specification text as we'd otherwise like, because we want to, because we're sort of manually translating these algorithms. So we want to sort of minimize the chance of human errors by things like code duplication. But like, since these things require some creativity, we might wonder how this could be integrated into the TC39 process.
So we could create a domain-specific language inside Rocq for the delegates to use when creating the specification. But do we expect them to actually write Rocq code?
Well, this might be a hard sell to the JavaScript community. But what we are currently trying to explore is to use already existing tooling that the community already is using and see whether we could benefit from that. So here I'm in particular talking about ECMAScript, which is a tool originally developed by Sukan Ryu from KAIST and her group. So essentially from what we need from this tool for this project is the fact that the tool parses the text of the JavaScript specification and produces an abstract industry. And then we can try to generate some Rocq code, at least for some of the functions, like maybe the more trivial ones, and then at least have it as a first step towards having mechanization as part of the TC39 process. But obviously we are far from there yet. The link to our repository is here. Thank you very much. We're ready for questions.
Questions?
You're probably aware that there was a paper on time published at CPP 2 or 3 years ago, which was about the discrepancy between years and physical years. Is it also considered by the standard that you're looking at?
So the specification of the specification of this proposal that the JavaScript committee considers, I don't think they have that, but I'm not entirely sure. At least the functions that we have mechanized were sort of the more trivial ones, so we didn't get to that point.
Any other questions? Maybe I'll have another one. So why did you choose to go with the largest proposal?
Well, we wanted to see how much we can actually mechanize, and whether even like mechanizing as sort of a small fragment, so essentially we have like less than 10% mechanized, would help finding bugs and in the specification itself.
How much of the, let's see, you said there was a fragment that you couldn't, sort of mechanize because it relied on JavaScript features. How much lies between sort of things you don't expect to verify and what you have verified? So how much more do you think you could feasibly mechanize?
Don't remember the exact number, but at least like twice as many function sets we have now, I think.
Okay. Around 80. Any more questions? Oh, I have one last one. I think on one of the earlier slides you were talking about sort of the second category of properties you might want to recognize. Expected behaviors, and I don't know, in my experience with JavaScript, I wouldn't expect adding 0 to something not into it. So
okay. To fix it.
Okay, with that, let's thank our 3 speakers once again.